Today, let's talk about AtCoder Beginner Contest 3A1 Problem E. First part is description. We are given an integer n and a string s. N is the length of the string. For every the character of the string should be three kinds of character. That means 1, 2, or slash. We are given Q times query. For every query, we are provide L and R. This is the data provided for us. There is a definition of 1122 type string. That means there is a slash in the middle of the string and there are several ones on the left of the slash, and there are the same amount of twos on the right of the slash. For example, this is a 1122 type string. In addition, this is also a 1122 type string, but this is not because the amount of ones on the left of the slash is not equal with the amount of twos on the right of the slash. Okay, in addition, this is also a valid 1122 type. For every query, that means for every L and R, we can get a substring of the S. That means S, L to R. This is the substring. What we need to do is find the longest subsequence from this substring and make it a 1122 type string. This is what we need to do. For example, let's take the problem. Let's take the problem in the original description at the example 111212. For example, this is the substring. Okay, the longest subsequence what we can get should be 11/22. That means this and this is what we need to meet the target subsequence. Okay, next part, let's talk about solution. Actually, for every query, we can, for the range problem, a very common problem is use the binary search. It is the same for this problem. Actually, for the L and R, what we need to do is find a very correct position for slash. After we find the best slash, we will know how many ones on the left of the slash and how many twos on the right of the slash. We will get the best answer. So the key point should be find a best slash, and the slash should be located in the middle of the substring as much as possible. So for the L and R, we can get a middle point. Middle point that will be equal L plus R divided by 2. In the next point, we need to find out the nearest slash position. For the middle point, we need to find the nearest slash position of the middle point. In addition, we can calculate the nearest slash position for every position before we process the queries. So we can make an intermediate array before we process these things. Okay, after we get the nearest position, what we need to do is how many ones on the left and how many twos on the right. Okay, this is how many ones and how many twos on the left and right of the nearest position between X and R. We can calculate this using the prefix and the suffix function, suffix array. We can calculate the suffix array. That means how many ones on the left of every position and how many twos on the right of every position or every index. We can calculate, we can make the intermediate array before we process the queries. So we can, that means, for example, in order to calculate how many ones we will know, we can use the prefix. We can make it as the near. The variable will be near. So the near minus prefix L. This is how we get how many ones. This will be suffix R minus suffix near. This is how to calculate how many twos on the right of near position. Okay, if the left, we can make it as the amount should be x and the amount should be y. If x is larger than y, we will know the best position. We need to change the position of slash and make the x should be equal y as much as possible. So we should move the slash position to the left more. So we will know the best slash should be in the range of L, and the best position for the slash should be the range of L and near. In contrast, if x is less than y, we will know the best position should be near to R. This is how we reduce the range of binary search. We can reduce the range size of the range one step by one. This is how to solve this problem. In the process, we can update the answer. That means answer should be the maximum value of mean value of between x and y multiply 2 plus 1. Yeah, this will be the maximum value of this value should be the answer. We can update it in the process of binary search. As mentioned above, we need to calculate some intermediate array before. For example, we need to calculate. Okay, the first array should be in the nearest position. Nearest array. This is the first. Actually, it will contain two arrays. I mean, what is the nearest point on the left of current point or on the right current point. So it will be two arrays, left and right. So the second should be prefix x. Prefix of ones. So the third should be suffix of twos. Yeah, this is what we need to calculate at an intermediate array. Okay, next point, let's talk about complexity. For this part, first part is term complexity. For the range of binary search should be 1 100,000. Let me equal n. So the binary search should be on. There are q times query, so the time complexity should be OQ multiply log n. Yeah, this should be the time complexity for every binary search should be log n. So, okay. This should be the time complexity. For the space complexity, the length of the string should be n, so the space complexity is also on. This is all about this problem. If you have any confusion, welcome to submit a comment. Thanks for your watching.